Hi, I'm Jeff. In this video, I'm going to show you a simple example of using the AXI DMA in Vivado. This is going to be based on a tutorial that I did in 2014, which you can see here. Now, I am going to refer to this diagram a few times. So just to tell you a little bit about DMA. DMA is basically an interface between a data producer or consumer and a memory controller. So you'd need a DMA if, for example, you have data coming in from an ADC and you need to store it very quickly into a memory, or in the other case where you have a DAC and you have data in a memory and you need to send that data as quickly as possible through to your DAC. In both of these cases, you could always use the processor to do this job. So the DMA is not the only solution, but obviously using the processor to transfer data from one place to the other is very time consuming for the processor, and it's a bit of a waste of the processor. The processor should be left to do intelligent things. So the DMA is really a hardware solution to transferring data from one place to another. And it is the most efficient way of doing so. So I'll get into the example now. In Vivado, we start by creating project. Now I'm going to base this one on the MicroZ 7010. So I'll call the project MZ7010 DMA. Let's say DMA test. Next. Now it's an RTL project, and I will not specify sources at this time because I don't have any sources for this. Here we select the board. So I'm going to select MicroZ 7010, and all that's going to do is configure this project for the right part depending on what hardware we're using. So I click finished. Now I can click create block design. I'll leave it with the default name. And the first thing I do is add my Zinc processing system to the design. I'm going to click run block automation. Now what the block automation is going to do in the beginning is apply the board preset on the processing system. So that's going to configure the Zinc processing system for the hardware that we're using. So depending on the board preset that we chose earlier, which means the DDR and whatever other IP or whatever other hardware devices we have connected to the Zinc, well, the board preset should configure that. So I click OK. Now in the block diagram, I can see that the DDR interface has been externalized. So I know that my Zinc is configured with the DDR to which it's connected to on the MicroZ. Now I also have fixed I/O port that is for all the other IP or all the other devices that are wired to the Zinc on the MicroZ. So if I want to know what they are, I could just double click on the Zinc PS and have a look at the block diagram here. I can see that I have a UART connected because I know the MicroZ has a UART or a USB UART on there. GPIO probably has some LEDs on there that are connected to GPIOs. There's an SD card on there, so there's an SDIO interface for that. USB port has a USB port, and Ethernet. So that's one of the Gigabit Ethernet Max that's enabled there and connected to the Gigabit Ethernet PHY, and RJ45 connected that's on the MicroZ. So the other thing the board preset is going to do for us is configure a clock for us. So we see here that we have one of the fabric clocks has been configured to 100 megahertz. So I'm going to use this clock for the whole design. Okay, so now what I want to do in this design, because I have an AXI DMA is going to need access to the DDR memory controller, and it's also going to need a configuration interface, which is going to be AXI Lite. So the processor is going to need to configure the AXI DMA through an AXI Lite port, and the AXI DMA is going to need access to the DDR. That's the important thing to know, because I need to configure the Zinc processing system for those things. So if I go to my Zinc block design, firstly for the DMA configuration, the Zinc is going to need a general purpose AXI master port so that it can configure the DMA. So that is, when I say configure the DMA, I mean set up DMA transfers and trigger them. That's what the AXI slave port's for, and that's what I'm going to enable here. So what I could do, the easy way to do it is I click on this block here, and Vivado takes me through to the right setting that I have to enable. So here I can see general purpose master AXI interface, and I tick that to enable the GP0 interface. So again, that's my interface that I'm going to use to configure the DMA from the processor. The other interface that I need is to access the DDR controller, the memory controller. And I can see from this diagram what I need to enable is one of these high performance AXI slave ports. So that would allow the DMA to read and write from the DDR. So to enable one of these, I have to click on that, tick one of those. There's 4 of them, I only need 1. So now I've got those 2 ports. The only other thing that I need to configure here is the interrupts. So I need to enable fabric interrupts, because I'm going to be receiving interrupts from the DMA IP. So I have to enable this IRQ F2P, which means FPGA to processor system. I enable that, click OK. So now my Zinc is properly configured. I can start off by connecting the fabric clock, the 100 megahertz clock, through to these AXI interfaces. My 2 AXI interfaces, the GP general purpose master AXI interface and the high performance slave. So here is my high performance slave, and here is my general purpose master. So that's that. Now what I can do is add my DMA. There's a few DMAs there for different applications. The one that I want though is AXI Direct Memory Access. So now what I can see is I've got an AXI Lite interface. That's for configuration of the DMA, setting up DMA transfers from the processor. And I've got these other interfaces here, which MAXI, or just AXI itself, is an AXI memory mapped interface, whereas AXI S is going to be the AXI streaming interfaces. So these AXI memory mapped interfaces are going to need to go through to the DDR controller or to the high performance port, whereas the AXI Lite is going to need to go to the general purpose AXI master. Then we have the streaming interfaces, and in our case what we want to do is we want to connect the streaming interfaces through an AXI data FIFO so that we can loop back the data. So that way our application is going to just send data from the memory through the DMA to the FIFO. That's going to be looped back to the DMA and be written back into the memory. So the processor can just verify that the transfer was successful by comparing the data that was sent and the data that was received. So that only leaves 2 ports here, which are the AXI streaming status and AXI streaming control ports. We don't actually need those. Those are used in Ethernet applications, so we're going to disable them. So that gets rid of them. So now I can start connecting my interfaces. So I'm going to run connection automation. I'll tick on first the AXI light interface, slave interface. It's always good when you're using connection automation to check what Vivado wants to connect things to. But here I can see it wants to connect the AXI light interface through to the processing systems general purpose AXI master port. That's correct, that's what we want. Now it can't really make a mistake here because there is only one master AXI interface configured on the Zinc at the moment. The other one is a slave interface, so the high performance port is a slave interface, so it's not going to use that. So that's right. Now I can tick on the high performance slave AXI interface of the PS. Vivado wants to connect it to the scatter gather AXI master interface of the DMA. Now it could have chosen any of the other AXI master interfaces. It chose scatter gather. It doesn't really matter because it's just going to create either an AXI interconnect or an AXI smart connect for this, and then the other two ports will be able to go through that as well. So anyway, we start things off like that. Okay, and if I just run through quickly what that's done, we just want to make sure that our general purpose AXI master port, that's going through now to an AXI interconnect, which is called peripheral. So that's for all your peripherals. Goes through here, out here, and it should go through to the AXI light interface of the DMA. So that's for configuration of the DMA and for triggering on setting up DMA transfers. So what about the master interfaces of the AXI DMA? We've only connected one of them for now, the scatter gather interface. So that goes through here, through to an AXI Smart Connect, and then this should go through to our high performance slave interface, which is basically access to the DMA, not to the DMA, to the DDR, sorry, the memory. That's what that has done. I'm going to run connection automation again to hook up my last two AXI master interfaces of the DMA. That's going to connect both of them through to the high performance slave port. So I click OK, and here they are. And all that's done is opened up two more ports on this AXI Smart Connect. Okay, so now I've hooked up those things. That leaves my AXI streaming interfaces to connect. So if I go back to the diagram, I'm talking about these two interfaces. So I need to add my AXI data FIFO and connect up the AXI streaming interfaces. So I go plus FIFO. I want an AXI full stream data FIFO. Okay, and I want to connect the AXI streaming master interface through to the AXI streaming slave interface of the DMA, and I want to connect the AXI streaming master interface of the DMA through to the AXI streaming slave interface of the FIFO. So that's going to be my loopback. The data is going to come out of here, memory map to streaming. It's going to go through the FIFO, and it's going to come out of the FIFO and back into the DMA, the streaming to memory mapped interface, and be written again to the DDR memory. So what about these things here? The FIFO needs to be clocked. We're going to use the same 100 megahertz clock that everything else uses. So I hook that through to there. And for the reset, I want to use the reset that the rest of my design is using, which is generated by the automatically generated processor system reset, the source of which is the fabric clock reset here. So that's what I'm going to use. So now that's all connected properly. The only thing that I have to connect up now are the two interrupts of the DMA. I need to connect them through to here, the IRQ F2P. The way to do that is to use a concat. So the output of my concat has to go to there, and then my two interrupts have to go to there. And my interrupts are now connected. So that's my design. I can save the block design now. I can click validate design to make sure I haven't made any mistakes or forgotten to connect any clocks or resets. Okay, so this is an intermittent problem that sometimes happens with micro Z designs. It's something that started, I think, a couple of versions ago, but you can safely ignore these messages. They're basically coming from the board preset, and Vivado is complaining about them now, whereas it didn't complain about them in previous versions. Anyway, so we'll just ignore those and save the design again. So now the only thing I have to do is to generate my HDL wrapper. So I click on that and I say let Vivado manage wrapper and auto update. Now the only thing I have to do is generate the bit stream. Okay, so my bit stream has been generated. I'm going to tick on view reports because I don't want to open the implemented design. Now what I have to do is I want to bring this hardware design into the SDK so I can run a software application on it and test out the hardware. So to do that, I have to say File, Export, Export Hardware, and include the bit stream. I'll export it local to the project. Click OK. So now the hardware has been exported for SDK. I just have to run SDK. So the easy way to do that is to go File, Launch SDK, and I exported it local to the project. My SDK workspace, I'll also leave it local to the project. It doesn't really change much for me here. So OK. So the SDK workspace at the moment has nothing in it, should have nothing in it except my hardware platform specification, which is here. It's got the name of the block design. So I've got to add my application to the SDK at this point. So the way I do that is I say File, New, Application Project. Now I can call this DMA test, like that. If I just look into what's going on here, here you can choose the processor that the application is going to run on. Now because the Zinc on the micro Z has a dual core ARM processor, so we can choose which one we want to use. I'll just choose that one. You obviously have to specify the hardware platform, or the hardware platform which is defined here. So there's only one that I got to choose from, so that's why it's choosing that. Now I tick next. What I'm going to do is I'm going to use an empty application for this. So that's going to be just an application with no code. I've got to supply the code, which I will do. So I'll say finish. So in my DMA test application here, I've got no sources, just a linker script, a readme. So to this, I'm going to have my software application. What I'm going to use as a software application is an example software application that is provided by Xilinx. It is in this folder here: Xilinx SDK, the version number, data, embedded software, Xilinx processor IP lib, drivers, AXI DMA, examples. So this is in your Xilinx installation files. So what I want to do is use the example scatter gather poll to begin with. Let's try that. So if I take this file, maybe I can drag it over here, copy files, click OK. So that's copied that into my software application. And now project build automatically. So I'm using the build automatically settings, so it should have built that project automatically. So now let's try to run that application. So first of all, you've got to make sure that you have set the jumpers correctly for the configuration of the Zinc. So here I've got the jumpers set for configuration by JTAG. So here I have my JTAG programmer here. Here's my JTAG programmer that I'm going to use. I'll just plug it in. Okay, and now I can plug in my USB cable and plug into here. And when I do that, the micro Z, you'll notice the LEDs turn on. That's because it's getting its power from the USB port. So now what I can do is go back into the SDK, click Xilinx Tools, program the FPGA, and I'll program. Now that's loaded the bit stream into the FPGA on the Zinc. Now all I have to do is run the application. But before I run the application, I'm going to set up a connection to it. So I've already set that up earlier. So here is my COM port terminal window connected through to the micro Z. So when I run my application, I should see some text coming up onto my console window. So to run the test, I'm going to click on DMA test application, click on run configurations, and I want to use the system debugger for this. So I double click on that, and I can then click run, and it will run the application on the hardware, and I can see here that the application was successful. Now just one last thing, I'll create another application. I want to run another application, but this time using the example application that has interrupts. I'll again choose an empty application and move and copy the application code into the workspace. Okay, so now I can see in the new application I have no code. So I want to grab this, the scatter gather example with interrupts. I'll drag it over into my application. Okay, now it's going to crash If you go and look and see why it crashed, you'll find that there are a couple of defines here that Vivado can't find. So if I hover over that, it says to me that this define is undeclared first use in this function. So that this is a define that should be in X parameters in the BSP. So I'm going to go and open up the BSP and see why that define isn't there, and maybe it's changed names. So I go on X parameters. Let me see, we're talking about interrupt. Let's search for this name and maybe I can find it. Okay, so here I can see that the defines that this application is looking for have changed names in this version of Vivado. So all I want to do is take the new names and modify my code with the new names. So this is the MM2S. MM2S, I'll change that. And then get the other one, S2MM, and change that one. Then save the file. It builds automatically, and I can see that now the SDK knows the interrupt vector IDs. So the application is built. I just have to run it. So I'm again going to say I'm going to click on the application. Click on Run Configurations, double click on System Debugger, and then Run. Okay, and when I run that, go back to my terminal window to see the output, and I see that it says successfully ran the AXI DMA scatter gather interrupt example. So that's my two examples working. At this point, I guess I leave you guys to muck around with the example applications, see what you can learn from the code. So thanks for watching and good luck with your projects.